Okay, now let's start with Zeek. Zeek, formerly called Bro, is not a signature-based IDS. It is event-driven. What does this mean? Zeek will look at your packets and then will tell you that, hey, I saw DNS, SMB, and these other protocols. You can do whatever you want with this information. It does not tell you that, look here, I found it bad. You have to analyze the output of that information. Zeek, at its core, is a programming language that can interact with network traffic and do whatever you tell it to do. The default logs are made by Zeek themselves. Let's take a look at them. So before we start with the Zeek demos, I first want to show you the configuration file. And what I want to show you about this configuration file is that normally inside it, SMB is not enabled. And because SMB is such a heavily exploited protocol, I recommend you guys to enable it and try it out and see if it works. If it does, keep it up, and if not, disable it again. Okay, let's start Zeek against the iodine DNS tunnel. Now here I've already ran it against it. This PCAP file on the tunnel is just one connection, which is the iodine connection, and further into the demos, we will see like bigger PCAP files with more connections. But what I want to show you here still is that, for example, on the con, what you can do is that you can go ahead and see the fields that are being used. And then what you can do is that you can run Zeek against it. You can copy the fields that you may like. And for example, I like these. Now here I have to put spaces between them. And after I do that, now let's say I don't want the ports, I only want the hosts, and that should be it, yes. And if you take a look, for example, here is a connection from this IP to this IP using the UDP DNS for 53, which is 24-second, interestingly enough. Now, another thing is that the UID is made by Zeek. And if there are, well, the events that are like connected to this connection are in other log files, you will find the same UID in the other files. So if I open up like the DNS log and grep for this ID, you will see that, as you can see, you'll see all the information that is correlated with that ID. Now, let's not do that. Let's just normally open up DNS log and let's take a look at the headers. And let's say I want the originating, the hosts and the responding hosts and not the ports. So let's remove the port. And I want the query and the protocol. No, let's, yeah, the queue type name. Oh, query type name. Not as HTML. And let's see. Is this enough? Oh, actually, yes, it is. So now this again is just one connection, but this is how a DNS tunnel would look like inside Zeek's DNS.log. You will see, for example, the connections that is happening from point A to point B, and inside the query, now for like DNS cat, this could be like txt, mx, or a CNAME, but inside the query, you will see hexadecimal information in like lengthy amounts. Here, you should only see, for example, I want query for, let's say, Amazon.com or whatever, not a long hex string. So this is how Zeek will show you something like a DNS tunnel. Now for our next demo, let's take a look at HTTPS. So here I ran Zeek against the PCAP file. Let's do the same thing with the con log. Now, just like before, let's copy this and then take a look at it. Now, what you can do, right, you can put the duration in the beginning and then and then do a sort by numerical value, and then what you'll get is that in the beginning, oh, it's weird. Oh, that's, oh, yeah. And in the beginning, you will get the highest seconds first. So if you take a look at here, we see that this host has connected this HTTP session, right, for a very long amount of time, a lot of SSL and some other HTTP in the beginning, as we can see. So let's first start with the http.log. So if you take a look at the http.log, we'll see that this person has connected to 3 websites. One of them is what is my IP? Let's say we don't care about that. He has connected to Tor, which means that he most probably has downloaded Tor, and he has been connected to this site, which was the one with the highest one. And well, maybe he was browsing or doing whatever. Now we have to ask, okay, is this a competitor? Is this a friend of our company that he's just visiting and it's normal, or he's being phished? You know, it could be either one of those. But we saw a lot of SSL now, so let's take a look of the options we have when it comes to SSL. We have the SSL.log and we have the X509 log. The X509 is only the certificate information, whereas in the SSL log, it is the X509 information and more. So you could just use the SSL.log and grab everything you need. So here you'll get like the destination ports and other types of information. And here let's grab the information that we care about. Let's grab the subject and the issuer, right? And let's grab the server name as well. You could grab some other information as well. Let's do a, oh, we can't do it like that. Okay, so that would be enough then. Let's do Zeek cut and paste those. Let's grab the server name, and let's just say this is enough for us right now. You know what? Let me just put the ID dot originating host and ID dot responding host. Yeah, and Zeek cut. We forgot about that. Zeek cut, and let's run it through less. And yeah, here we go. So inside the X509, you will see the subject in the issuer. You won't get the server name though, and you won't get the responding and the originating host. Now, 2 possibilities could be here. A, either our employee was phished from that first website and he is using Tor and browsing Tor websites, which could be against our policy, or it could be either one of them. Either way, what we see here is that we are seeing non-normal HTTPS certificates and websites, which again could be either the phished website or just using Tor. Either way, this is something that again we have to investigate, and this is how you would see abnormal certificates inside Zeek, and this is how it show you. And at the very bottom, if you go to the Tor one, which is normally like the website itself is normal, as you can see, this is how normal certificates would look like. You will have like the CN, you will see the country, and for example, DigiCert gave them the certificate. Stuff like this is normal and everything else is abnormal. So this is how you would find HTTPS abnormality inside Zeek. So for our last Zeek demo, let's do a log4j demo. Now this pcap file is a very busy pcap file. If you do a cat on the connection log, and if I just show you the number of lines, oh yeah, there are many of them, right? But what we do know about log4j, that it's inside HTTP, right? So if we go inside the http.log, and now how many lines is this? Yeah, it is quite many. But we know that inside log4j there is the string jndi, and if we do that, what we'll get is, ding ding, we'll get the, first of all, the UIDs that you can use to correlate with the other logs. And also we find that, for example, this host and this other host, both of them have been trying to send JNDI exploits. So, for example, most of them have used LDAP. Here, it has been inside the URI, and for the other ones, I don't exactly know where this is, but I think you get the point that if you know what protocol is being exploited, and if you maybe even know a little bit about the payload, you can find and use Zeek its different logs to find your events of interest. So this is how Log4j looks inside Zeek. Onto Suricata. Suricata is a signature-based IDS, meaning that there are rules that the packets will be checked against. It is very similar to Snort. The output is in JSON, and we will parse it using JQ on the command line. Now, if you take a look at their documentation, there are optional logs that you can turn on, but the main log is the Eve log. And while this is a signature-based IDS, there is some amount of event-driven information inside this log as well. Let's find out how the rules work and operate. All rules should have an action. The two actions that we mainly care about are alert and pass. In the header, you first have to specify a protocol. Depending on the IDS's features, you may have access to layer 5 protocols. Then you add the IP address ranges and the ports with the direction. Now, you will commonly see variables called homenet for your own IP ranges, and then the variable external net, which will be not homenet. Meta keywords do not affect the rule, and they are only informational, but they are critical in understanding the rule. This is the part that we specify the state of the packet and the direction of the flow. Now, almost always the state will be established. Remember, the machine that initiates the connection is the client and the other side is the server. Now, for this, you have two options. Either you can specify from the server to the client, which both keywords are equivalent, or you can say from the client to the server, which again, the two keywords are equivalent and do the same thing. It's just a matter of perspective. The content is the payload that you're looking for. You can just set the content and be done with it, but it is important to make your rules efficient so that the IDS doesn't go under heavy load and be able to inspect all the packets. To understand the content filters and how they work, refer to the documentation. If several contents exist and you want one of them to take precedence, you can use fast pattern. Here is an example. We are alerting on HTTP. Because we specified HTTP, we don't need to specify the port. The message tells us it's the default user agent form interpreter. The flow is from the client to the server. The HTTP header keyword allows us to easily make our rule efficient without the need for the filters. The content is the user agent, and the rest is informational, like how many times it has changed and the last time it was updated. Now let's do a few demos with Suricata. Let's first start with the eve.json log. I do want to add that the TLS log is a optional log that you can turn on, but for our purposes, it does not matter. Now, eve.json is a JSON log. Normally, we cannot interpret this. So what do? We use a program or a tool like JQ, which makes it far more easier to understand. Now, before we do that, I want to show you the event types that Suricata has. And while I said that Suricata is a signature-based IDS, as you can see in the alerts and in the anomalies, it does have event-driven information that you can use as well, which is quite useful actually. But with that said, let's focus on the alerts. Okay, now let's take a look and see how we can parse the eve.json log with JQ. Now, JQ has a manual that is amazing and I highly recommend taking a look at. for now, we'll stick to the basics. And one of the first things is the select option, which is great because, well, with it, you can select the value of your choice. Now, depending if the value inside it is a string, you have to use the quotation marks, right? So now we said that we want alerts, right? So that's what we're looking for. So we take a look at it and it's like, okay, so there's a lot of invalid checksum in this pcap file that I ran against. So let's do this, right? So let's say I don't want this signature, right? So what would you do? We first, well, whenever you do something right with JQ, you have to then go into another pipeline. Although there could be exceptions, but for now, let's just say that's the case. And what I do now is that, okay, I want to find and select this, right? So important thing is that this field is inside the alert. So what I have to do is that I have to select dot alert dot signature. Let's just copy and paste it. And then I say I do not want it to be equal to this value. Again, copy and paste, easy. And now if we let this run, we should be good. Yeah. Now we have information about, well, severity ones, severity twos, most likely. Yeah, as you can see, so this is like a TLS heartbleed. So now we got the junk out of the way, and now all the information that is left and is information that we care about. And again, let's say that I want only severity one. If you only want severity one, you can even delete this as well. You can just go back and do this for severity one. First find severity, I guess under alert, then do alert dot severity equals 1. Pretty simple. And close that up. And yeah, now we should only get severity 1. So for example, this one is a CVE, which if we take a look, oh yeah, here it is. It's CGI. CGI is, yeah, as even the payload is actually there as well, which is really nice. You see the user agent and it's a shell shock. So the adversaries have been trying to see if it's like, oh, they've been trying to ping themselves. Oh, I guess I'm assuming this is a private IP, but you get the idea that with this now, I have information to severity 1 alerts. Now again, let's say I want, where is it? Okay, here it is. I want the signature ID, right? Because the signature ID is how you can, it's a really good field to essentially be able to search on things rather than the other fields that exist. Because again, it's the SID. Like, what else do you want? It is really good. So now I've chosen these. So what I do again is that in these, I was like, okay, where is signature ID? Signature ID is again inside alert. So what I do is I don't need to select, sorry. I do dot alert dot, and again, you can just copy and paste it, write it, doesn't really matter. Signature ID, and let's just see the normal. Yeah, so this is the normal value. If you want to get a better view of this, put it inside sort and then unique, and then you do the -c to count them. And now we should get, yeah, so now here are the signature IDs of well, severity 1 alerts in my network, assuming that this pcap file is from my network. And as you can see, easily with one line, we were able to find the signature IDs. And now with the signature IDs, I can do whatever I want. Again, depends on your goal. For now, I just wanted to showcase you how you can use JQ against a JSON log. So I hoped that you enjoyed this. Okay, so for our last Suricata demo, I wanted to show you creating a few roles, and I wanted to talk about ICMP, right? And how we would whitelist it. So here I have a payload, right? So, well, I don't have a payload. I have an ICMP PCAP file, right? That I have gathered the payload that we need to pass, right? So one of them, I think one of them is for Linux, and the other one, oh, sorry, this one, I think this one is Windows, and this one is Linux, from what I remember. So we have two payloads, right? And this is our whitelist good ICMP. Now, obviously, this list can be more. You can have maybe like Cisco devices. You may have different specific tools that will have different payloads of ICMPs, but generally, ICMPs tend to have static requests, whereas a exfiltration or anything else, a shell, a C2, is going to be different. So we are now going to whitelist this. So the things that I did is that if I let me check where it is. It's there. So let me show you. I don't actually need to use sudo, but whatever. I added inside the rule files another rule that so we can be able to work with, right? And if you come here inside the rules, which for me is under the libraries, the vested rules, yes, it is empty. So we're going to be making them. And we have the payload and we have it also. Let's make the rules. Now, first, what we'll do is that we will create the alert, right? And with the alerts, oh, that's on read only. What we'll do is that we'll create the alert, we'll see the alerts happening, and then we will create the whitelist. So first the alerts. Now, here I will put any because I really don't care. And I want to see, right, all sorts of weird ICMPs coming from outside to inside and from inside to outside. So I don't care which way it's happening, right? And then for the message, let's call it ICMP exfil, right? Whatever. You can call it whatever you like, but this is the one I'm going to choose. And then now to cheat a bit and make my own life a little bit easier, let's do this. Let's go under our lib and then Suricata rules. And what you can do is you can run this, and for the, I would say, the fields that you want to type, you can, take a look like this and make your life a little bit easier. Now, oh, I just remembered, yeah. So a request in ICMP, right, has an I type. Oh, I actually forgot something. Oops. ICMP. So ICMP in the beginning, any. Okay, that's good. We have the options down, we have the other down. Now for the options and the contents, let's first do the contents. Let's do I type, right? Type 8. And the I code is going to be 0 because this is how a ICMP request is. You can open up Wireshark and take a look at it if you want to. And if you want to make sure, you can do this. You can grep for ICMP and forgot the pipe. And you should see other rules. Again, like this is good rule creation, right? Using I codes, as you can see, and I types. It is good and recommended, in my opinion, to just open up the rule files, and if you want to create a new rule, just take a look at what they've done and try to make your rules just like them, efficient and effective, right? So that's that. And you want to alert on those. Let's say the revision is 1. The SID is I took a look at the SIDs that exist. I saw that like 4 million is generally like empty. So we'll choose 4 million. We could give it a class type, but that doesn't matter. We have the message. We don't need content because we are alerting on everything ICMP related. And let's see, what else? Fast pattern, we don't care. And metadata, let's see if we don't care about those either. So this should be enough. Let's see if this will work. Yeah, why not? So this is saved. If I run Suricata and I run the checksum on none, so it makes my life easier. If the checksums are broken, I don't need to deal with them. So now it should read on the rules and we should get several alerts for the requests that we have. Okay, so Suricata is done. If we take a look at the event types that exist, and as you can see, we have the alerts that were the requests that were inside the PCAP file, right? And these are all good ICMP packets. So let's whitelist them. So we do the same thing. Any. Oh, and I forgot ICMP again. Okay, no problem. Message is going to be let's say Windows ICMP, and again we will use the same itype and icode. Revision 1, and SID is 4,000,001. Now, for the contents needs to be this, because I went inside Wireshark and I took a look at the payload. Very simple. And if we just need to put it inside the strings, and that should be enough for this one. And for the other one, we'll just do it right here. Let's call this Linux. Grab the payload. Grab the payload. Put it inside here. Change the ID to something else. And I think that is it. Okay, so I forgot about these semicolons. Add those in, and then run the tool again. Okay, the tool is done. Now let's take a look at the ave.json log, and now we should not get any more alerts. And there it is. It is done. So what I want you guys to take from this rule creation, right, demo, is that it's not about sitting down and writing the whole thing down. It is about knowing the payload, because the payload for you is going to be unique to other people. And the rest is just about using documentation, using the rules that were already made to make your rule as efficient as possible. So I hoped that you guys enjoyed this. And we are done with the course. I'm happy that you took the time and put the effort to learn all of this. And if you use it, well, that would be wonderful. Farewell and good luck.